and we are over in our assembly area, and everybody's gonna give us a hard time because it's empty. That doesn't mean the process has not started, let me tell you. Let me take you for a quick walk around. I showed some stuff last night where I was laying underneath the car and how proud I was with what the guys did, but now I'm gonna take you around our chassis. And these are final cars that are production cars. And we're finally to the process that the standard is high enough that we can accept it. So I will share with you exactly what we're calling good, what we're not calling good, and how we're gonna work to make it better. So check this out. I'm gonna flip the camera around, give me a couple minutes here, and I'll take you for a nice little walk around. This is one of our black chassis. This has been E-coated, so it is inside and out E-coated. It does have thermal drilled holes in the chassis. So those are thermal drilling. That's where not a hole, it basically swedges the material in and makes a thread. Dan, you want to talk about that a little bit?
Yeah, it's pretty cool because it doesn't just like cut into the material and you're left with a really thin wall thickness with sharp edges. It forms the actual wall of the tube and stretches it down deep and folds it over the top, and then it comes in and threads that. So you're really left with a stronger and more continuous piece of material.
Yeah, and what the difference is instead of getting, let's call it 1 or 2 threads when you drill and tap, we've got about 4 or 5 threads in there. That is really just for holding on plastics. This isn't for supporting metal. But let me walk you around the chassis here. This is our chassis. This is a production welded chassis. This is not something we built at RGM. This is done by robot. This has passed my standards. All right, this has passed the speed standards. I am 100% good with the quality of this product, and this is what customers are going to receive. Now, if you think we're joking, do me a favor. Walk around a current Polaris or Can-Am. You take your camera over there and then compare videos, because this is what we've worked on, and this is part of the delays, is making sure that we can teach the robot to get every single weld speed quality. All right, this is everything. We've got corner gussets built into the car as a production vehicle. We have corner gussets built in here. Check those welds out. I compare this stuff right here to what Jamie Campbell does. I think Jamie Campbell is awesome, does a wonderful job. He welded my Pro 2 with Johnny Kaiser. That is Kaiser Campbell standards right there. Same thing up here. This is the corner gusset on the support of the, I call this the A, the B, the C, the D, and the E post, okay? This is the welds. We argue about this all the time, right?
If you look at a car, this is A no matter what, and you can have 2 posts as A and then A plus, and then B, and then C and C plus.
See, we do fight about this, okay? I'm gonna turn the camera around, and we do argue about stuff internally, okay? I call one thing one, he calls it something else. At the end of the day, it's safety. It's quality, it's safety. It's what we promised you guys back at Sand Sports that we would do. So I'm gonna flick the camera back around, walk you through this chassis. This is our battery brackets, okay? This looks like something that would be on a trophy truck or on my SST trucks. It's almost identical to my SST truck, but it also integrates a seatbelt mount, and we put lightning holes in it to clean it up. All right, there is things we can continue to work on for future models. Is dimple dyed holes here, dimple dyed holes here, dimple dyes over there. We will work on that on the RGs, and we'll bring them up to, oh, this guy's saying Daniel's right. Come on, HSD, you're giving me a hard time here. This is the door. We had a lot of complaints about the door and about the mechanism here. Now look at, we've got a lot of room. It's flush here, nothing sticks out. Clean welds. These are really, really hard to do when you're putting a flat plate onto a round tube. That's really hard. All right. Rear door hitch, definitely overkill. We'll work on that for the future. We can save some weight here. That was one of the first parts that we designed, and as you see, we left it. Shock mounts, full trophy truck style. This is what we did originally on the Riviera truck. The shock mount tied into the pivot tied in the junction. There's corner gussets down in here. This is like what you would see on a full-blown trophy truck. This isn't a piece of tubing with a couple plates welded to it. This is 120 wall thickness, shoulder all the way through, proper rear suspension, rear geometry. Forged corners over here. The reason for forging these guys, both of them are forged. This one's forged as well, is to keep the tolerance for easy fitment. Slides right in. Also gives us a nice plug. We weld it deep inside here. Comes with Nerf bars, so there is Nerf bars. People didn't understand when I said Nerf bars. I call them Nerf bars. Some people call them, kicker bars. I would like to see them bigger, but unfortunately I didn't want to stick it outside the plastic. But this is made so someone can actually step up on the plastic and step into the car to make it a little bit easier. We really focused on this bar here to make sure there's enough room to step between the driver and passenger. A lot of people complained about the double X, about how hard it was to get in, especially John Menard complained about that. So we've taken all these complaints and really listened to what the customer says and tried to improve on it, which is not always the easiest thing to do. So shock mounts, welds, it's...
Show all the tubes down there.
Yeah, I mean, into this guy here, yeah. So into the shock mount, there's a gusset support from here. So there's a triangulation coming from here. Then this is a big old structure. It ties into here. It's got gussets. It ties into the chassis, comes all the way down into the node down here with a triangulation. This triangulation meets up in here, so that supports the inner pivot of the trailing arm. When you look at the trailing arms, this is going to be something for a lot of people. A lot of people think this adjustment right here with the rod end is for the trailing arm adjustment for tow. That is not what it's for. That is our axle adjustment, and that adjusts axle plunge inside and outside. So if you adjust this and you think you're doing it for tow, you're doing it really wrong. We'll make sure that we explain this in the future as we go through some of our builds, but just wanted to get it out there. This is not a tow adjustment. The tow and camber is built into the trailing arm, which is located back here. You just don't see it right now, but that is built into there. And then we will have camber wedges and tow wedges if people do want to throw more camber or tow into it. But if you throw more camber into it, remember you're going to have to take some wheel travel away. I heard that Justin from Shock Therapy said that he likes a 5-link suspension compared to what we have. I'm going to walk you over this car and give you just a little example about how some people just don't understand the physical mass of what happens with geometry and lateral load. There is zero possibility that a 5-link is better than a trailing arm. If you watch a Polaris come into a corner and they side load, it actually, because the radius rods are heading uphill, it picks the back of the car up, the car changes track width by 10 inches, gets narrower, and tips over. It is probably the worst design you can possibly ever come up with for lateral load. The other thing is you have a ton of tire scrub. Okay? Yes, you can get a little bit more wheel travel. I think he made a mistake, but I believe we're at 22 inches conservative, and we can get 24 if you want to push your CVs to the maximum level. You don't need any more than that when you have a proper shock absorber, okay? A lot of people will band-aid more wheel travel for not understanding shock technology. But with shock technology, if you look at Nasser's Dakar car, that thing has won the overall at Dakar many times with 11 inches of wheel travel. 11 inches of wheel travel, proper shock technology, will go very fast, okay? We have double that. We have double what Nasser has won at Dakar with multiple times. Now I've climbed underneath the car here. This is something pretty interesting. If you look, there is no cage on the car right now. Nothing. It's all open. Motor's bare. We have a patent on hanging the motor, okay? This is one of our ideal patents that a lot of people probably don't understand we're doing, but we can actually load this motor into the car as a complete assembly. It can slide in from the back, all the way assembled with muffler, exhaust, turbo, intercooler, wiring harness, CVT, everything plugs in at one time. So the cool thing about this is if you smack the bottom of your cage, you are not putting your suspension out of alignment. It stays in alignment. So this is done. This is something we have a patent on. This is something that will stay for a very long time. Shock technology we talked about in one of my videos the other day. Look at these production A-arms. I'm going to go lay on my back underneath here and show you this stuff up close. But look at the welds on these production trailing arms. It has interior gussets. That's what these little pieces are here. It does have interior gusset supports. It ties in. It has everything we have like our trophy truck. Now this trailing arm is the same trailing arm as that one. People say, well, how do you do that? If you look, it's even got the brake line tabs built into the bottom down here, which work as drains for us. But if you put the suspension, the shock, and the sway bar on a parallel line, you can flip it from left to right really easy. Now let's get into suspension geometry. I'm going to take you over here to suspension geometry, and I want you to think about this. So if I'm going to have camber on the car, how did I do that? And how is that happening? Well, this pivot point inside here is actually lower than this one, and it is at a degreed angle. Okay, so that means as it goes through the travel, it changes camber. It changes camber, but it doesn't change more than a 1/4 inch of track change. All right, what it does more importantly than anything is when you laterally load this car from the bottom with the tire patch, it takes the geometry and pushes on this interior pivot point. And the way that the geometry is, it's opposite than Polaris or Can-Am. So I'm going to come back to Daniel. What is the roll center difference between a Polaris Can-Am and a Speed UTV?
Well, at what ride height?
At what ride height? Okay, let's just start at static ride height.
So our roll center stays very consistent. At static ride height, it's about 2 inches off the ground.
Okay, and where is the Polaris and Can-Am?
So their roll center is about 10 to 15 inches off the ground at ride height, but then it goes crazy when you droop it out. And it goes to the moon.
To the moon, which is jacking. And basically when you get lateral force, you get jacking force, which raises the back of the car up. Boom. Track which gets narrower, flips over, and now you've got a situation. So not only by quality of design, but by quality and design of suspension, we have the competition in a box. Truly, we have them. Actually, I think we have them in a cage. They are so trapped inside a cage. We have decades of advantage on them. And as we continue to improve our CV technology, we will get more wheel travel, but I am pretty confident with 20, and as you see, we have more than a 1/2 inch of axle plunge at full droop, and we have more than 22 inches of wheel travel front and rear. Now I'm going to walk you into here where you can see inside the car. This is a car that has been put together. This is raw, but we put it together so that we catch every single little potential flaw we might have. All right? We have shipped cars to Sand Sports as well. There is the front bulkhead. This thing assembles, I sent some pictures of it. All day Polaris, you just don't have a clue, dude. All right, let's go into the front hydraulic steering. So this has a hydraulic steering rack similar to what a rock crawler, Ultra 4, trophy truck, pretty much everything. There is no fast off-road race car that wins overall Baja 1000, that wins King of the Hammers with electric steering. Let's get this straight, guys. This is a hydraulic ram here. So I'm gonna come down underneath here and I'm gonna show you the hydraulic ram built up inside here. So there's the hydraulic ram. It now has these forged plates that tie this whole thing together, and it goes on the front bulkhead. The front bulkhead ties into the chassis here. All right, spindles, A-arms, hydraulic steering. All right, another feature that we have, very new to the UTV industry, something, Daniel, can you show me your phone, please? It has a crushable steering shaft. And what that means is, like a NASCAR or an IndyCar, it has a collapsible steering shaft up inside there. So as you see, that steering shaft is splined and it collapses up inside. Our wiring harness, this is not the final wiring harness, so please don't comment on that. The wiring harness is broken into 3 sections, has a front section, a rear section, and a main chassis harness. Actually, it has 4 sections. And it has its own engine harness that stays on the engine. Beadlock wheels. Corner gussets. All right, you're gonna see a red sticker here. Let's talk about this red sticker. This is a red sticker because they told me it was too hard for the robot to get down inside here and finish that last 1/2 inch of weld. Well, when they said that, I came over here and said, well, how did they do it over here then? And they've gotten so good with this thing, they were able to do it back here. We want it done in the front too. This is corner gussets that Bill Savage wanted. He's a tech inspector for Pikes Peak, Score International, Best in the Desert, UTV World Championships. We have shared our designs with a lot of highly educated people. Corner gussets here, corner gussets here, corner gussets down in the feet. This car is built by race car designers, drivers, Baja SAE engineers, a lot of Baja SAE engineers. I think everybody on our program, maybe, was Matt on Baja SAE?
Matt was before.
Matt did not go to Baja SAE, but everybody else was Baja SAE. We will continue to hire people from Baja SAE. They do a great job. They teach these guys young, then we can take them from here and bring them into real world vehicles. Truck bed, how cool is this? Full truck bed built in, production. You don't have to go buy a spare tire rack. You don't have to buy something to hold your spare tire that blocks your rear view mirror. Air intakes, we'll do more of this walk around stuff later. Air intakes, all way high up out of the water, about shoulder deep. Universal front hubs, universal unit bearings, front and rear. Same shock, all four corners, just different valving. Same trailing arms, left and right. Same lower A-arms, left and right. Same upper A-arms, left and right. Different valving shocks. Got some technology there. We're waiting on a couple new patents that will keep us leader again. Shock therapy will like this because we don't need limit straps. All right. Who's making the transmission? We make our own transmission. We make our own engine. We make our own gearbox. Now, does that mean we don't work with somebody? Yes, we worked with Albans on the transmission engineering side of it, but it's a lot of stuff that Daniel and Matt worked on. And then Albans oversaw it and said, hey, I would do it like this, or I would do it like that and make it a little bit better.
And Sean at Weddle helped.
And Sean at Weddle, Ron and Sean at Weddle. Let's make sure that we get them in there.
Yeah, they definitely helped us out with all their tolerances and crush fits on the bearings that they take and do in their race prep, and got us that in stock form so that when the case is heated up, the bearings have the right amount of preload on them.
Thank you for that, Daniel, because that brought it a little farther than where I was going. So, we build our own gearbox, we build our own engine, but we also do it with a lot of help from a lot of industry experts. All right, walking back into the chassis one more time. Here's the painted one. I showed you the painted one. Now let's go to the raw one, because obviously when it's painted, powder coat will cover up a lot of stuff, all right? That right there, that got a red dot, okay? That is not acceptable, all right? This is acceptable. This is acceptable. This is acceptable. This is acceptable. This is questionable. This is questionable over here. This has a stainless ground. We gave you guys a stainless ground right from production, okay? Unfortunately, they dropped a BB from the welder on there, and that thread is jacked up. Acceptable, 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 acceptable. Production has started, okay? These are not me building a couple cars in my shop. This is robot fixtures. How many fixtures? 150 fixtures? So many, it's crazy. Tooling up the yang. Somebody say we're making friends? My dad taught me a long time ago, when you go to the racetrack, you bring your friends with you. He also taught me to keep your spares in the cooler. I want to thank everybody that was an early supporter of Speed U TV. Without you guys and girls believing in me and believing in our abilities and believing that I would follow it through all the way to the end, I want to thank you. I want to let you guys know that this is very personal to me. Remember, I have worked for Polaris. I think everybody knows what the RZR on Polaris stands for, okay? I worked at Polaris. They told me they surpassed my engineering abilities. At that point, this turns personal. See you guys on the racetrack.